Thank you for joining us today. And in this video, we are still on Leibniz rule. Let's jump right in. So this question is so interesting in a such a way that we have our integration with respect to x, but we have two constants, alpha and beta. And this one, it depends on how you want to go about it. You can you can decide to differentiate with respect to alpha, or you can decide to differentiate with respect to what? Beta, but I'll choose alpha, right? So when I choose alpha, I'm going to have I of alpha to be equal to 0 to 1 alpha x minus, sorry, x to the power x minus x to the power beta divided by ln x dx, right? So I chose alpha to be the constant here that I want to integrate with respect to. So now let's see what is going to happen here. Now I differentiate both sides with respect to alpha. So differentiate with respect to alpha, 0 to 1, x to the power minus alpha minus x to the power beta divided by x ln x dx. This is the same as I prime alpha, which is the same as integration from 1 to 0 to 1, differentiate alpha, x to the power alpha minus x to the power beta divided by ln x or dx. Now this can be written as, so as you can see, we can take this one out. We've done some before, x, then we take partial with respect to alpha of this minus beta dx, right? So this is going to give us 1 over ln x, then with respect to alpha, right? So since we don't have alpha here, this one will go to 0. Then when we integrate this, when we differentiate this, I think we've done some before, where I said the base is constant because we are differentiating with respect to alpha. So this is going to give us x to the power alpha times 1 times ln of the base. So that is what you are going to get. And then this will cancel that. So as I said, this is like an exponential function where x is the base and it's a constant, and you are differentiating with respect to alpha, right? So an exponential function, maintain the function, differentiate the top, and pick ln of the base. So that's what you are going to get. So this is going to give us 0 to 1. Then we have x to the power alpha dx. So when I integrate this, I'm going to have x to the power alpha plus 1 divided by alpha plus 1 from 0 to 1. I think we've done something like this before, but just something small. I think the only thing that is changing is the one that we did was here was 1, and now this is not 1, but it is what? X to the power beta, right? So this is going to be 1 alpha plus 1 divided by alpha plus 1 minus 0 alpha plus 1 divided by alpha plus 1. And this is going to give us 1 over alpha plus 1. And then this side will go to 0. So it means that I prime of alpha is equal to 1 over alpha plus 1. Yeah, I think we've done something like this before. So what we need to do now is we need to integrate with respect to what? Alpha. So we are going to have integrating this with respect to alpha, integrating this with respect to alpha. We are going to have I of alpha to be equal to ln of alpha plus 1 plus c. So as we said, we need to go and pick the function, pick alpha such that we get the other side to be 0. So now let's pick the function here, copy it, let's paste it somewhere here. Now here, we want to choose alpha. So we need to look for where alpha is. This is alpha. And then the function here is x to the power beta. So what should we pick? What should be alpha? so that this function here will be the same as this. And of course, it should be what? Beta. Because if this one becomes beta, then x to the power beta minus x to the power beta will be 0, and everything here will be what? 0. So it means that our initial function here will be I of beta n is equal to 0. So this happens when this is beta. So when we plug our initial condition now to this, we are going to have I of beta to be equal to ln of beta plus 1 plus c, right? And this is going to give us, now I of beta is equal to 0. So you're going to have 0 plus 0 equals ln beta plus 1 plus c, and c now is equal to minus ln beta plus 1. So this one was so nice because we didn't get it to be 0. So this is this to be equal to ln alpha plus 1 minus beta plus 1 minus beta plus 1. Right. So this is what we are going to have for the function. And if you want to apply the properties of ln, then we can write this one as ln alpha plus 1 divided by beta plus 1. So this is what you are going to have at the end of the day. So when you choose the other side, let's assume that you chose beta. When you choose beta, you are going to get the same results. But the only thing is here will be beta and here will be alpha. So you are going to just swap this and that. So that's what you are going to get. So I think that's so. So as I said, choose this one to be equal to I. Look for your constant function and differentiate. When you are done, you integrate. For you to get the initial condition, pick the original function, try and figure out what is alpha. That will make this one 0, and then we'll use it to do the process. See you in the next video.